So one of my questions regarding the video of this physics CPT is what is the max height and range of the object, which is the rocket fired? So the video gives me a few variables: the initial time, which is 1.5 seconds, the final time, which is 3.5 seconds, and subtracting these two, 3.5 subtracted by 1.5, gives me a total time traveled of 2 seconds. Now I can use the formula 0.6 times 1040, and I use this because it'll give me the max height of the rocket. After doing a few calculations, I decided to use equation 3 of the 5 key equations, and this was to find the initial velocity of the y. And I'm doing this to plug it into another formula which will allow me to find out the max height of the rocket during its time of travel. So some variables I plugged in here: acceleration 9.8, which is gravity acting on the rocket. This 0.5 is from the 1040 times 0.6, and the time here is 2, and that is because that is the total time of travel on the rocket from the final time subtracted by initial time. So finding out the initial velocity in the y from the previous equation, which did equal to 9.55, that allowed me to plug it into this equation and find out the max height, which ended up being 4.65 meters. Now I added 0.5 because that is the length of the object, so adding that to the 4.65 would equal to a total max height of 5.15 meters halfway. So again, by using the 9.55 that I got, which is the initial velocity in the y, I use it in this equation along with 1040, divided by that equals the velocity in the x. And 11.38 is the velocity of halfway, which is the max height. So that's why I use the 9.55 here. Now multiplying that by 2 is, of course, the total length, which gives me the range. And the range of this object equates to 22.76 meters. So using all of the information that I gathered from the kinematics unit, I can use that to relate to the energy unit, and I can use those variables to find some potential energy and kinetic energy. And the variables I got from the kinematics unit is the max height, which is 5.15 meters. And I was also able to get the velocity in the x, which equals to 11.38. So by using the variables that I got in the kinematics equation, I was able to sub them into both the potential energy equation and the kinetic energy. So in the potential energy, I used the max height of 5.15 and the mass, which was given in the video. And this gave me a potential energy of 0.7 joules. And for kinetic energy, I used the 11.38, once again from the kinematics equation, and the mass, which gave me a kinetic energy of 0.9 joules. So to explain my findings even more, here's a parabola I drew. As you can see, I have distance traveled in these are both in meters. The distance traveled in the x, height in the y. As you can see, this is how you would visualize the rocket. It would start, get launched, all the way to a distance of 11.38 meters and a max height of 5.15 meters. And that's how I can use kinematics and energy to relate to this physics problem.